This video is on applications of rational equations. And I think I'm going to go through this in several videos just to split it up a little bit. But you know, if you're in my course, you should be able to find this packet as a PDF right next to the videos. And you know, basically, you're going to solve word problems. Some of them are going to be contrived examples, like the first few, and then we'll talk about some, applications that might have some real life implications. So, for the first one here. We have one number is 7 times larger than another. The difference of their reciprocals is 11. Determine the two numbers. So, first thing when you're solving a word problem, you should be asking yourself, is how many things am I looking for? And in this case, looking for two numbers. And the number of things you're looking for will determine how many let statements you're going to need. Remember, you want to define your variables first. This is part of the process. This is what I expect to see if you're doing this on a homework assignment or on a test. So, we need two let statements because we're looking for two unknowns. So I'm going to let x equal, and I'll just say let x equal what we'll call the first number. Remember, a let statement is a way of defining your variables. It's not an equation. So we're going to let x equal the first number. It says one number is 7 times larger than the other. So 7 times this number would be 7x. So this would be the other number, which I'll just call the second number here. So we have the two numbers, x and 7x. And then once you have your let statements for each of your unknowns, then you want to write an equation. Now the equation comes from the words here. It says the difference means subtraction, of their reciprocals. Make sure you remember what reciprocal means. Reciprocal means, essentially flip the fraction, right? So if I had the number, 2/5, the reciprocal of that would be 5/2. If I had the number 4, the reciprocal of 4, since 4 would be the same as 4/1, would be 1/4. So it says the difference of the reciprocals is 11. Determine the two numbers. So what's the reciprocal of the first number? Well, the reciprocal of x, this is x over 1. The reciprocal of that would be 1 over x. Difference means you're doing subtraction. And then the next number, we had 7x. We want the reciprocal of it, though. So that would be 1 over 7x, because this is really 7x over 1. So this is the difference of the reciprocals, and we know this is going to be equal to, the is telling you it's equal to 11. Don't take the reciprocal there. Something to point out is that we know 7x is bigger than x, so that when you take the reciprocals, 1 over x is bigger than 1 over 7x, because it would be a larger denominator for the 7x, so that means that this number would be smaller. And that's how you know the order here, because our answer had to come out positive. So now once you're here, you solve this like you normally would for a rational equation. So the first thing you need is a least common denominator, or lowest common denominator, for all the fractions that appear. In this case, the LCD between x and 7x is 7x. Remember, you want the highest power of x you see. And then what you do with the LCD, remember, is you multiply it to every single term. So once you set it up, the math part, the algebra part, is not that bad. So we have 7x times 1 over x minus 7x times 1 over 7x equals 7x times 11. Make sure you are multiplying it to every single term. If you don't do it to every single term, then you're not keeping your equation balanced. So even if it's not a fraction, you still multiply by the LCD. That's what keeps the equation balanced. And now remember why we did this. We're trying to clear fractions. So 7x times the 1 over x, the x's are going to cancel. You're left with 7 times 1, which gives you 7. Minus here, 7x times 1 over 7x. Well, the whole 7x will cancel with 7x. It's really just a 1. 1 times 1 just gives me minus 1. Equals here, 7x times 11. Remember, you're multiplying these. This would be 77x. And now fractions are gone. If you didn't clear fractions at this point, that would mean that you didn't pick a good LCD. You didn't pick a common denominator at all, actually. So now once we're here, combine like terms. 7 minus 1 give us 6 equals 77x. And we want to solve for x. Remember, to solve for x, we're going to divide by the coefficient. So we're going to divide by 77. Make sure you divide by the correct value. Sometimes people look at the smaller number, and that's not it. It's really whatever's in front of x, the coefficient of x. So I end up with x equals 6 over 77. Now, if that reduces, you would reduce it. In this case, that does not reduce. So we got x equals 6 over 77. Make sure we answer the question. Did we answer the question? Well, we're looking for two numbers. Now in this case, we found x, which is the first number, so we know that this is 6 over 77. What's the second number? Well, you find the second number by using your let statement. Your let statement says 7x equals the second number, so the 7 times x, which was 66, or which is 6 over 77, sorry. And then you want to simplify this. To simplify this, 7 and the 77 will cancel to a 1 over 11. So you got 1 times 6 over 11, which equals 6 over 11. You could also do 7 times 6, which is 42 over 77, and then reduce. So 6 over 11 will be the second number. 6 over 77 is the first number. If you wanted to write these as a solution set, you could write it as 6 over 77, comma 6 over 11. Remember, this is not an ordered pair, it's just a set. You could even write them in the opposite order, but those are the two numbers that follow these properties we talked about. The only other thing I'll mention here is make sure you go back and answer the question. Sometimes people do all this solving here, but they didn't actually answer what the question asked. Let's take a look at another one. So we have the sum of a number, and 3 times its reciprocal is 28/5. Find the numbers. And that little s there means there could just be one number, or there could be multiple numbers that do this. So first, when you're looking at this, it's the sum of a number and 3 times its reciprocal. So you're really only looking for one thing, right? The number that does this, the sum of a number and 3 times its reciprocal. It's not the same as the previous example where we actually were trying to find two different numbers. So we're going to let x equal what we'll call the unknown number. And we'll let x equal the unknown number, and then from there we're ready to set up our equation. Now remember, the equation comes from the words in the problem. So we say the sum. Sum means we're using addition, remember. So of a number, x is the number. So we'll have x plus, this is the sum, 3 times its reciprocal. That's important to understand. So first you got to take the reciprocal, and then you take 3 times it. So what's the reciprocal of x? Well, that would be 1 over x. And then 3 times that would be 3 times 1 over x. This is 3 times its reciprocal. Be very careful. Sometimes people will write 3x here and they put 1 over 3x, and that would be wrong, right? That's a different thing. This is 3 times its reciprocal. The reciprocal is 1 over x. 3 times that is 3 times 1 over x. The word is, remember, means equals. So this is equal to 28/5. Now once you have that, now you want to solve this equation. Keeping in mind that you could probably simplify this part here. We have x plus 3 times 1 over x. This is really like saying 3 over 1 times 1 over x. The way you multiply a whole number times a fraction is you multiply right into the numerator. So 3 times 1 would be 3 over x. And then this x plus 3 over x equals 28/5. And now we have a rational equation. And to solve a rational equation, remember the first thing you need is to try to clear fractions by using the LCD. And for the LCD in this case, right, you want the least common denominator between 5 and x. Well, you need the factor of 5, and you also need the factor of x, so it's 5x. And then remember what you do with it. You're multiplying 5x to every single term, whether it's a fraction or not. So you have 5x times x plus 5x times 3 over x equals 5x times 28/5. And now we simplify. Now 5x times x, don't cancel these. This is straight multiplication. There's nothing to cancel here. So 5x times x is 5x squared. Plus the next term, 5x times 3 over x. Remember, the idea is that you're going to clear fractions. Here the x's cancel, so you're left with 5 times 3, which is 15. And it equals, here, 5x times 28 over 5. The 5's cancel, so I'm left with 28x. Okay, and now we want to solve this. To solve this, notice you have the highest power of 2 here. It's a quadratic, so you want to get everything to one side and 0 on the other. To do that, I'll subtract 28x from each side. So this leaves me with, if I go up here, I have 5x squared minus 28x, writing it in descending order, plus 15, and then don't forget equals 0. Now you want to factor this, and when you go to factor this, you could use either the AC method, or you know, a reverse FOIL. The first thing you should do is look for a GCF. In this case, there is no GCF other than 1. I have 3 terms, and I see a value in front of the x squared, and that's what's telling me either AC method or reverse FOIL. Maybe I'll use AC method just to kind of do a little refresher on it. AC would be 5 times 15, which equals 75. You want things that also add to B, which is the middle coefficient, which is negative 28. And the way you do this is you rewrite the middle using the values that you find here. What numbers multiply to positive 75 but add to a negative 28? Well, adding to a negative tells you that they both have to be negative, and then multiplying to a positive, so they both have to be negative. So we're looking at negative 25 and negative 3, because negative 25 times negative 3 would give you 75. Negative 25 plus negative 3 would give you negative 28. So we would have 5x squared minus 25, make sure you bring the x with it, minus 3x, make sure you bring the x with it. We're replacing the middle there, and then the plus 15 stays the same on the end. I'm not going to, really go too deep into this AC method. You should know how to do this from earlier in the course. The 5x squared minus 25x, you need a GCF there, which is 5x. Factoring it out, you end up with x minus 5. Here we factor out a negative for sure, because the first term is negative. The 3 and 15 have a 3 in common, so we have negative 3. And then we have x minus 5. We need to divide each of these by negative 3 to factor it out. This all equals 0. So then these have x minus 5 in common, times 5x minus 3 is what's left over from the front of each. This whole thing equals 0. Now, I went through that AC method pretty quickly. At this point, if you're using AC method, you have to be able to do it fairly quickly. You can't spend a lot of time on it because it's always going to be part of a larger problem. If you're using reverse FOIL, you still could have been able to get here. Notice the 5x squared would be the 5x times x, and then things that multiplied 15, you would have had to have done trial and error to figure out negative 5 and negative 3 would be what fits in there. But you can still get there. Now don't stop here. Once you've factored it, remember you still want to solve. When you solve this, you want to set each of them equal to 0. So I set x minus 5 equal to 0. I set 5x minus 3 equal to 0. Here I'm going to add 5 to each side, so I get x equals 5. Here I add 3 and add 3, so I get 5x equals 3, and then divide by 5 and divide by 5, I get x equals 3/5. So I had 2 answers. Right, that's 3 there, might not be clear. So I get 2 answers, right? So my solution set, I can write as 5 and 3/5. Remember the curly brace is indicating it's a set notation, right? And these are the solutions that make this original equation true. So the unknown number, see how it said numbers to the left here? If this didn't come out to a quadratic, if you just had x to the first power in here, you only got 1 answer. Because it was a quadratic, we got 2 answers. So there's 2 answers that if you take the sum of a number and 3 times its reciprocal will give you 28/5. Either subbing in 5 to here will do this, or substituting in 3/5. So there can be more than 1 answer, but it all depends on the type of equation that you set up. Let's take a look at one more. Alright, so we have the numerator of the fraction 3/8. Right, so just the numerator of the fraction 3/8 is increased by an amount so that the resulting fraction has a value of 9/4. Determine the amount by which the numerator was increased. So if I'm looking at this, I really have to think to myself, okay, how many things am I looking for? Well, it says determine the amount by which the numerator was increased. That's one thing. So I'm going to have one let statement, and we're going to let x equal, what are they asking us to find? The amount by which the numerator was increased. So x is going to equal the amount the numerator was increased. Now, when you do this, think about what I'm talking about. The numerator of the fraction 3/8. Which part's the numerator? Well, the numerator is the top, right? The 3. So if I go to write the equation, the numerator of 3/8, the 3 is getting increased by some amount. Increased by means you're adding to it. So 3 plus x, make sure increased by means to add. So it's increased by an amount. But the denominator didn't change. So we have 3 plus x all over 8 is really what we have here, right? The numerator is being increased by an amount so that the resulting fraction has a value of 9/4. So this is going to be equal to 9/4, and that's how you get your equation here. So it's 3 plus x all over 8 equals 9/4. This is a little different than what you typically are used to seeing. Usually what you're doing is you're manipulating, you know, some type of equation based on what they tell you, not manipulating a specific term. And here, though, we're manipulating a specific term, and mainly the numerator of the term, the 3. But this is what it's really saying. Increase the 3 by some unknown amount to make it equal to 9/4. So once we have this, to solve this equation, we have a fraction equal to a fraction. Well, how do you solve that? You could multiply by the LCD to each side, but typically, from what we learned earlier, if you have a fraction equal to a fraction, you're allowed to cross multiply. It's the only time you can cross multiply. So cross multiplying here means go down this cross. 3 plus x times 4 will be 4 times 3 plus x. And then it's always equal to multiplying going up the opposite cross. 8 times 9 in this case is 72. And then fractions are gone. If you had multiplied by an LCD of 8 to both sides, you would have gotten to the same place. But either way, you're okay here. So when we get to this, we have 4 times 3 plus x equals 72. We can distribute through with the 4. So 4 times 3 will give you 12. 4 times x will give you plus 4x equals 72. And then I will subtract 12 and subtract 12. We end up with 4x equals 72 minus 12, which is 60. So I have 4x equals 60, and then we want to divide by 4, and you get x equals 15. So what that really tells us is that we put 15, right, 3 plus 15. If we had that, it would be 18 over 8. Does that equal 9/4? Well, it does if you were to reduce it. So the solution set here we have is just 15. Either you can write it as x equals 15. If we ask for set notation, make sure curly braces on both sides and then the values that you need in the middle. The only other thing I'll mention is that if you use the LCD here, like I said, you'll get to the same place. You multiply both sides of this by 8. What happens is the 8's would cancel here. You'd be left with 3 plus x equals 8 over 4, give you 2 times 9 is 18. So 3 plus x equals 18, which eventually would solve to x equals 15. So either way is okay, but if you see a fraction equal to a fraction, cross multiplying is a quick way to clear fractions. It's only when you have a fraction equal to a fraction, though. So we'll work in the next video on the rest of this packet, but I just wanted to make sure you had a start on it with just the numerical examples.